Have you ever looked at a massive airplane and wondered, how does it actually stay in the air? It's not magic, it's a beautiful balance of four invisible forces working together in perfect harmony. Gravity pulls the plane down as weight, while the wings generate lift to push it toward the sky. Thrust moves the plane forward while drag, or air resistance, tries to slow it back down. The secret is the shape of the wing, called an airfoil. It's curved on top and flatter on the bottom. Faster air over the top creates lower pressure, which literally sucks the airplane upward. Engines provide the massive thrust needed to keep that air flowing fast enough for the wings to work. It's a masterclass in physics. Next time you fly, remember, you're riding the wind. Happy flying!
Ever wondered how airplanes fly? It's all about physics and engineering working in harmony. Flight depends on four forces. Lift pulls up, weight pulls down, thrust pushes forward, and drag holds back. The wings generate lift by creating a pressure difference as air flows over their curved surfaces. Engines provide thrust. Jet engines compress air and blast it out the back to push the plane forward. To climb or descend, pilots use elevators on the tail to control the airplane's pitch. Ailerons on the wings control roll, allowing the airplane to bank left or right during turns. During takeoff, flaps extend to increase lift, helping the heavy plane leave the ground safely. The pilot manages these forces using the yoke, throttle, and rudder pedals in the cockpit. That's the science of flight. Thanks for watching, and safe travels!
An airplane flies by balancing four fundamental forces: lift, weight, thrust, and drag. Lift pushes upward. Weight pulls downward due to gravity. Thrust moves the plane forward. Drag resists that motion. For steady flight, lift equals weight, and thrust equals drag. The key to lift is the wing shape, called an airfoil. The top surface is more curved than the bottom. Air splits at the leading edge. Because of the curve, air traveling over the top has a longer distance to cover. To meet the air at the trailing edge at the same time, the top air moves faster than the air underneath. Bernoulli's principle states that faster moving fluid produces lower pressure. So above the wing, air pressure drops. Below the wing, slower air creates higher pressure. This pressure difference, high below, low above, generates an upward net force, lift. Newton's third law also contributes: for every action, there is an equal opposite reaction. The wing's angle of attack pushes air downward. That downward action on the air produces an upward reaction on the wing. Lift is therefore a combination of Bernoulli's pressure difference and Newtonian deflection. Thrust comes from engines. Jet engines suck air in, compress it, add fuel, ignite the mixture, and blast exhaust out the back. Propellers work like rotating wings, they pull air backward, pushing the plane forward. Thrust overcomes drag, the resistance of air against the plane's surface and shape. Pilots control lift using movable parts. Flaps and slats extend during takeoff and landing to increase wing curvature and area, boosting lift at low speeds. Ailerons roll the plane left or right, one goes up, the other down, changing lift on each wing. The tail controls pitch and yaw. The elevator on the horizontal stabilizer tilts the nose up or down by changing lift on the tail. The rudder on the vertical fin swings the nose left or right. Together with ailerons, they give the pilot full three-dimensional control. During takeoff, engines produce maximum thrust. As speed increases, airflow over the wings grows. Lift increases with the square of velocity. Once lift exceeds weight, the airplane leaves the ground. Flaps are deployed to generate extra lift at lower takeoff speeds. In cruise, the pilot reduces thrust to match drag. Lift equals weight. The plane maintains constant altitude and speed. Slight adjustments to elevator trim keep the nose level without constant control input. To land, the pilot reduces thrust, causing a descent. Flaps extend fully to allow slower flight without stalling. Just before touchdown, spoilers rise on top of the wings, breaking the smooth airflow and dumping lift. Weight then settles onto the landing gear. If the angle of attack becomes too steep, usually above 15 degrees, the smooth airflow separates from the wing's top surface. This is a stall. Lift suddenly drops, and the plane falls. Recovery requires lowering the nose to reduce the angle of attack and restore normal airflow. In summary, wings generate lift using Bernoulli's pressure difference and Newton's downward deflection. Engines provide thrust to overcome drag. Control surfaces manage direction. Four forces in balance allow a heavy metal machine to fly through the sky. Thanks for watching. Subscribe for more Science Explained.